Hello and welcome to this course on regular expressions. Regular expressions, or regex, define a search pattern that can be used to search for things in a string. Now, this course focuses on using regular expressions in JavaScript. However, almost everything you learn about regular expressions in this course can also apply if you're using regular expressions in another programming language. My name is Bo Carnes. I will be teaching this course. I'm with freeCodeCamp.org. In fact, this whole course is based on the free curriculum at freeCodeCamp.org. It's not required to go through that curriculum to also do this course, but it could be helpful. However, this course is designed to be standalone, but if you want to go through the curriculum on freecodecamp.org as well, you can look in this picture where it has the arrow right to the regular expressions part of the curriculum, so you can see where that's at. Well, let's get started. Regular expressions are used in programming languages to match parts of strings. You create patterns to help you do that matching. So, for instance, if you have this sentence, the dog chased the cat, and you want to match the word the, you can use this regex here. You can see that there's a slash, then the word the, and another slash. You will also notice that quote marks are not required within the regular expression. So, JavaScript has multiple ways to use regexes. One way to test a regex is to use the test method. The test method takes the regex, applies it to a string, and then returns true or false if the pattern matches something. So in this example, we have the string hello world, we have this regex, and we have my regex. I'm going to do dot test, and then inside the parentheses, I'm going to put my string. So we are going to see if my string contains this regex, which is hello, and then we'll put it into the result. In this case, it will be true because hello world does contain the string hello. Here we want to match the word Waldo. We have this sentence, somewhere Waldo is hiding in this text. So I'm going to change this regex. Instead of search, it's going to be Waldo. Now, one thing I want to point out is that this is case sensitive. So if I had a lowercase w, then this would not match. But since this starts with an uppercase W, I have to make the regex start with an uppercase W also. So this result, the Waldo regex.test Waldo is hiding is going to return true because it found Waldo in this sentence. Regex has an OR operator, which is a single pipe character. So in this example, let's say we want to try to match for multiple words instead of just a single word. Let's say we want to match dog, cat, bird, or fish. So what I would do here is I'm going to change this. I'll do dog, and then I'll put pipe, which is just a straight line up and down, and then I'll do cat, pipe, bird, pipe, fish. So this is going to match any of these four words, dog or cat or bird or fish. And since one of these words is in this sentence, this test is going to return true. So far, all the regexes we looked at matched literal strings. So the case mattered. If it was a capital letter, that's completely different from a lowercase letter. You can match both cases using what is called a flag. So there's the I flag that ignores case. So let me show you how you would do that. Let's say we have free code camp, and we'll see it's all lowercase in here, but we want to match it no matter what the case. So we want this to also match this, where there's a capital C and another capital C. So just after the last slash, I'm just going to put an I. So this is the flag. This means ignore case. So now when it tests the string freeCodeCamp for the regex, which is freeCodeCamp all lowercase, the result will be yes, because they will match. So far, we have just checked if a pattern exists or not within a string. But we can also extract the actual matches that we found with the match method. So let's see how to extract the word coding from this string. So we'll just change this to coding, and then here we'll use the .match method, match, and then in the parentheses we'll pass in coding regex. And then if we just run this, we'll see in the console coding because it's logging out the result. See, the result extracted this word coding out of the sentence and into the result variable, and it got logged. So far, we've only extracted search patterns one time, but it is also possible to search or extract a pattern more than once using the G flag. Let me show you what I mean. We have this test string up here, repeat, repeat, repeat. Now we're going to search for repeat. And the way it is now, when it matches this, it's only going to return the first repeat, just this one. But if we add the G flag after the slash here, it's going to find every single occurrence of the word repeat. So it's going to return an array with 3 elements, and each element is going to be the word repeat. Let's see it again down here where it says twinkle, twinkle, little star. I want to match the word twinkle. So I'll type in twinkle right here. And you'll see that the first twinkle is capitalized, the second one is not. So I'm going to have to use a flag. I'll have to use the I flag, which makes it insensitive to case. So it's case insensitive. I'm also going to add the G flag. That's going to match every single time twinkle appears. So you can use 2 flags at once on the same regex. Now here, for the result, it's going to be twinklestar.match, and then I'm going to pass in the star regex. Okay, now we'll log this and see what happens. You can see twinkle, twinkle. The first twinkle in the console is the capital T, and the second is the lowercase, because it matched the first one and the second one and returned them both. In regex, a period is a wildcard character. It can stand for anything. So let me show you an example. We have these 2 strings up here, and the first one has the word hum, the second one has the word hug. You'll notice that these 2 words start with the same 2 letters, HU, and then the third letter is different. So look at this regex here, HU period. This will match any word that starts with the characters HU and then has a final character, which could be any character. So if we look down here, we are going to take the first string, I'll hum a song, and match it to our regex. It's going to return hum. And then when we take our second string, bear hug, and match it to our regex, it's going to return hug. So let's try that with another sentence. We have this sentence here. Let's have some fun with regular expressions. So I want to match the word fun, but I also want this regex to be able to match the word run, sun, pun, none, or bun. Basically, any word that ends with UN and starts with another letter. So I'll change this regex to .un. So when we run our regex and search this sentence for something that ends with UN, it should find fun. So let's load that and look in the console. And it says true because it matched the word fun in that sentence. We talked about the wildcard character, which matches basically anything, but you can also match from a predefined group of characters. If we look at this right here, we have the B, and then we have these brackets, and inside the brackets, we're saying that the second letter that it's going to match has to be one of these 3 letters. So we know the first letter is going to be B, the last letter is going to be G, and the middle letter is going to be A, I, or U. So this would match bag, big, and bug. So down here, what we want to do is change this so we match every single vowel in this quote sample here. So what I'm going to do is put open and close brackets, and inside I'm going to put the vowels A, E, I, O, U. And then to make sure I match every single vowel and I match uppercase or lowercase vowels, I'm going to use flags. I'll use the I flag and the G flag. Now, down here, I'm going to have to do quote sample dot match, and then I just pass in the vowel regex here. If I run this in the console, you'll see all the vowels from that quote sample. You can also match a range of letters. So let me show you how to do that. Right here, I'm going to try to match every single letter. So I'm going to put the open and close brackets, and instead of typing A, B, C, D, E, F, G and writing every letter, I can just put A through Z. So it's going to match every letter between A and Z. And then to make sure it matches every uppercase and lowercase letter, I'll do I, and then G to make sure it matches every letter in the whole string. So now I can just do quote sample match, and then I just pass in the alphabet regex here. And if I run that, we should see in the console, it has every letter in that string. Just like you can use a regex to match a range of letters, you can also match a range of numbers. So if I want to match a range of numbers, it will be like this. I'll have the brackets here, the opening and closing brackets, and this time I'm just going to match the numbers 2 through 6. So I'll just put 2-6. So that will match 2, 3, 4, 5, 6. Also, in the same regex, I can match a range of numbers and a range of letters. So if I want to add some letters, I can put H through S. So now we can see this is going to match a range of numbers 2 through 6 and also a range of letters H through S. So I can do an I to make it case insensitive and a G to match every occurrence in the whole string. So I'm going to put that into my results. So I'll do quote sample dot match to match this regex. And then here, it's going to console.log the result. So let's see what happens. And we have every letter and number between those ranges. We've talked about how to match for specific characters, but what if you want to create a set of characters that you do not want to match? These are called negated character sets, and you can create them with the caret character. So let me show you how to do that. We want to make a regex that will match everything except all numbers and all vowels. So we are going to put a opening and close bracket, and I'm going to put a caret character that's right underneath a 6 on a keyboard, and I'll put 0 through 9. So we are not going to match all digits 0 through 9, and we are not going to match A, E, I, O, U. And then I will put my flags here, I, G, so this will match everything except 0 through 9 and A, E, I, O, U. So to finish this up, I'm going to put quote sample dot match, and then I'll pass in the regex here. And now I'll just run this, and you can see we've returned everything except the vowels and the numbers. It includes the spaces and periods and punctuation also. Sometimes you want to match if a character occurs one or more times. If you want to do that, you can use the plus character. So let me show you how to do that. In this case, we are going to try to match in the word Mississippi whenever an S occurs one or more times. So I'm just going to put S plus. And I'm going to put a G to match it every time it occurs. And if I run this, you'll see we've matched the first SS and then the second SS. If there just happened to be another S in here, we would then match 3 times. And you can see the third time it only matches the single S because there's only one S in a row. There is an option to match characters that occur 0 or more times. That's with this star character here. So this regex means match a G and then match an O 0 or more times. So with this word goal, it's going to return G-O and then every O after it. And then here, gut feeling, there's a G with no O's after it. And since it's matching 0 or more times, it's going to match that and just return G. Now this one has it has an O's, but it doesn't have a G. So it's going to return null. It's not going to match at all. So down here, we are going to do some coding and match A 0 or 1 time. So I'm going to change the change word here. And we always want to get the capital A. And then for the lowercase a, we are going to do a asterisk. So it can match this whole thing of A's here. So if I just do a console.log here and do a result, it should match all of the A's. It worked. I am going to talk to you about greedy and lazy matches. A greedy match finds the longest possible part of a string that fits the regex pattern and returns it as a match. A lazy match finds the smallest possible part of the string and returns that. Regex patterns default to greedy. Let me show you what I mean. Let's look at this string here, Titanic, and we'll look at this regex to find something in the string Titanic. First, we're looking for the letter T, and then this part means after the letter T, we want 0 or more of any letter. So remember, this means any letter A through Z. The asterisk or star means 0 or more occurrences of this A through Z. And then finally, we're looking for a letter I at the end. So when we run this match here, it's going to do a greedy match and find this, Titani. So it's going to start with a T, it's going to have 0 or more letters, and end with an I. However, if we put a question mark here, it's going to be a lazy match. So it's going to start with the T, and then remember, this is 0 or more occurrences. So instead of having all these letters, we're going to go to the 0 occurrence and not have any letters, and then end with this I here. So it's just going to be TI. So a greedy match would be TITANI. A lazy match would just be TI. So let's do the same thing down here. We have this string here, which is a bit of HTML with an H1 tag, some text, winter's coming, and a closing H1 tag. If I run this now, you'll see in the console, it's going to return the whole thing. So we're going to start with the more than sign here, and then we have the dot, which is a wildcard character. So this means any letter or character, and then the star or asterisk means 0 or more occurrences. So this means 0 or more occurrences of anything, and then we end with the greater than sign. So we're going to start with the less than sign right here. This is to open an HTML tag. And then we have the dot, which is a wildcard, the asterisk or star, which means 0 or more occurrences. So when you have a dot asterisk, that means 0 or more of occurrences of any character, and then end with the more than sign or the closing tag here. So it's going to go from here, and then it's going to have 0 or more occurrences of any character all the way to this final character here, this greater than sign. So what we're going to do is change this. So instead of getting this whole thing, which is greedy, we want to do a lazy match where it starts here and just ends at the first occurrence of this greater than sign. So all I have to do for that is to add a question mark. So if I run this now, you'll see in the console, it just has the opening H1 tag. This is a basic regex challenge. So here is the scenario. A group of criminals escaped from jail and ran away, but you don't know how many. However, you do know that they stay close together when they are around other people. You are responsible for finding all the criminals at once. So the criminals are represented by a C. So you can see here, we have these 3 C's together. These are all the criminals. So we need to write a regex function that's going to match anytime there is 1 or more C's in the string that's passed in. So this is how you would do it. It's actually pretty simple. We're just going to put a C and a plus. So it's going to match 1 or more C's. And if we load that, you'll see that it matches the CCC. And we solved the challenge. You can match patterns that are only at the beginning of a string. Previously, we talked about how the caret character inside a character set is used to create a negated character set. Well, if you're not in a character set, if you're not in brackets, you can use the caret character that looks like this to only match at the beginning of a string. So here, I'm just going to match the word cal if it's at the beginning of a string. So if I load this, you can see true because it is the cal is at the beginning of the string. However, if I take the word cal off here and put it in the middle here, and I reload that again, it's going to say false because it does not match it anymore since cal is not at the beginning of the string. A caret matches a beginning string pattern. A dollar sign matches an ending string pattern. So if we want to match the word caboose at the end of the string here, we'll type in into the regex, we'll type in caboose, and then I'll put a dollar sign. If you remember when we were matching a beginning string pattern, we put the caret at the beginning, but when we're matching an ending string pattern, we put the dollar sign at the end. So if I run this, we'll see true because it's at the end of the string. Now, if I actually move this over here and I run this, we'll see false. It's no longer at the end of the string, so it no longer matches caboose. Earlier, I showed you that this, with the brackets and A through Z in it, would match any letter A through Z. There's something called a shorthand character class that's used to match a wide range of things. And there's one called /W that you can use to match the alphabet. So if I put /W here, that's going to match capital A through Z, lowercase a through Z, the digits 0 through 9, and underscore. So just doing /W is just a shorthand way of pretty much matching any letter or number plus underscore. If I put a G after this, that will make it match every occurrence. So if I load this up, you'll see that it returns 31 because we're getting the length. The length of this whole string, excluding the spaces in the period, is 31. There are 31 letters in this string. /W matches all letters or numbers. But sometimes you want the opposite. Sometimes you want to match everything that's not a letter or number. So in this code, we want to just match everything that's not a letter or number, which are the spaces and the period in the string here. So instead of a /lowercase w, we're going to use a /uppercase w. And then I will put a G to match every single occurrence, and we're going to get the length here. So if I run that, we get a length of 6. There are 6 characters, those are the spaces and the period, that are not letters, numbers, or underscores. There is a shorthand character class to only match numbers or digits, and it's /D. So if I put /D here, it's going to match the digits here, which is the 5, the 0, and the 0. To match every single one, I'm going to put a G at the end for global, and then now the length should be 3. So if I run that, we'll see 3 in the console. Sometimes you want to match all non-numbers. If you remember, this /D, a lowercase d, would match all numbers, and the G made it match every occurrence of a number. So if we change this to an uppercase D, this is going to match all non-numbers. So that's going to be every single character in this whole string except the 5, the 0, and the 0. So we'll run this to get the length of that, and we get 24. We are going to create a regex that can be used as a username validator. In this case, there are three requirements for the username. So here's the first requirement. If there are numbers, they must be at the end. Second requirement, letters can be lowercase and uppercase. And then the third requirement is that it must be at least 2 letters long. 2 letter names can't have numbers, which is kind of a fourth requirement. So let's create the regex here. So first we are going to do the requirement that the numbers should be at the end. So if the numbers should be at the end, then letters should be at the beginning. So to specify what's at the beginning, we are going to use the caret sign, and then we're going to specify the letters that can be at the beginning, which are lowercase and uppercase letters. So I'll do A through Z uppercase, and then A through Z lowercase. So now it shows that at the beginning is going to be A through Z uppercase or A through Z lowercase. And to specify the number of letters that are going to be at the beginning, we're going to use the following. I'm going to put a curly brace, 2, comma, in curly brace. The curly braces indicate the number of times the previous thing can match. So the previous thing are these letters, and these can match anywhere between 2 and infinite number of times. So the number before the comma is the minimum number of matches, and the number after the comma is the maximum number of matches. So we know that every username is going to start with at least 2 letters, and since there's no number after the comma, it can have an infinite number of letters in the username. If we wanted it to have at max 8 letters, then we could put the number 8 after the comma. But since we don't care about the max, we're going to leave it as nothing after the comma. So next, we want to show that the numbers must be at the end, and you can have any number of numbers. So I'll put /d, and that represents all numbers. I'll put a star. So this star or asterisk means that there should be 0 or more. So this means 0 or more numbers. And now to show that the 0 or more numbers are at the end, I will put a $sign. We can now run this regex to make sure a username meets all of these requirements. We can match white space characters with /s. So /s is going to match a space, a carriage return, a tab, a form feed, and a new line character. So if I add a G for global and run that, we will see an array of all the spaces in that sentence. The white space is important in separating words sentence. Now I'll show you how to match all non-white space characters. First, make a guess. So remember, this is how you match white space characters. And if you've been noticing the pattern so far, you'll realize to match non-white space characters is just a capital S. So if we run that, you'll see an array of every character that's not a space. You can specify the lower and upper number of pattern matches with quantity specifiers. Quantity specifiers are used with curly brackets. I actually talked about these a little bit before. You put 2 numbers between the curly brackets for the lower and upper number of patterns. So let's say I want to match anything, any oh no, where the number of H's is between 3 and 6 H's. So what I'll do is type oh no, but after the H, I'm going to put these curly brackets and put 3, comma 6. So this means we're going to always match the letter O, and then we're going to match the letter H, but we only match if there is in between 3 and 6 H's. And then we'll also match this space in O. If we had not had a number here and we just had 3, comma, and the nothing in the in curly brace, then it would match for an infinite number of occurrences. So it would be 3 H's through an infinite number of H's. But we'll just leave it at 6. Here's another example with quantity specifiers where we're going to match 4 or more of the letter Z. So I'll put the letter Z and then the curly brackets, I'll put 4, comma, and then there will be nothing after the comma. Because like I said before, when you have nothing after the comma, there's an infinite number that it could go to. So it has to be at least 4, and then it can be an infinite number of Z's. We can use quantity specifiers to specify an exact number of matches instead of just a lower and upper bound. So, if we want to search for the word timber with exactly 4 M's, you can do it like this: TIM, and then I'll do the curly braces, and then just put the number 4. And then BER. So remember, before we had the lower bound, then comma, upper bound. But if we know we want exactly 4 M's, we can just put the number 4 in the curly braces. You can specify the possible existence of an element with a question mark. This checks for 0 or 1 of the preceding element. It's kind of like saying that the previous element is optional. For example, there are slight differences in American and British English. So the word favorite can be spelled with just an O or with an OU with British English. So let's create a regex that searches that can match both forms of the word favorite. So do favo, then I'll put a U with the question mark, RITE. So this is saying that it may have a U or it may not have a U, but all the other letters have to be the same. Look-aheads are patterns that tell JavaScript to look ahead in your string to check for patterns further along. This can be useful when you want to search for multiple patterns over the same string. There are positive look-aheads and negative look-aheads. So let me show you how they work. So this right here is a positive look-ahead. So we have parentheses and then we have a question mark. So the look-aheads always start with a question mark, and then it's going to be equals for a positive look-ahead or an exclamation point for a negative look-ahead. So let's look back at the positive look-ahead. So question mark equals means a positive look ahead and U. So it's first going to check for the Q, and it's going to look ahead to make sure there is a U later in the string. And if there is a U later in the string, we'll return just the Q. So when we run this regex on the quit string, it's going to return Q because it finds the U later in the string, but it doesn't return that U. A negative look ahead, it's going to make sure that something is not later in the string. So here it's going to search for a Q and make sure there's not a U later in the string. And if there is not a U later in the string, it's going to return this. So when we run this look ahead on the no quit string, it's going to find the Q and it's going to look ahead and find out there is no U. Since there is no U, it's just going to return the Q because that's what we have before the parentheses, and it's going to return the Q here. A more practical use of look-aheads is to check 2 or more patterns in one string. So down here in this example, we are going to use look-aheads in the PW regex to match passwords that are greater than 5 characters long and have 2 consecutive digits. So for a greater than 5 characters, we'll do parentheses, and then it's always going to start with the question mark equals if it's a positive look ahead, and I want greater than 5 characters. So /W would be all numbers and letter characters, and we want there to be 5 characters, at least 5 characters. And then we also want 2 consecutive digits. So I'm going to make another look ahead, question mark equals, and we're going to say there can be any number of characters that are not digits. This capital D, this /D is character that's not a digit, and the asterisk means there's 0 or more characters that are not a digit, but we also want to make sure that there are 2 or more digits. So we have the /d to say that there are going to be digits, and then we have 2, so there's going to be 2 or more digits. So this is going to match for 5 or more characters and then 2 or more digits. You can group things you are searching for in a regex with parentheses. So here we have parentheses around here. So we are searching for any number of characters, and then after that, there's going to be a space. You can also use these parentheses to repeat substrings. So this is called a capture group, and you can repeat this group any number of times. So in this regex, we have this first group in parentheses, and we can repeat that first group with a /1. If we had another group with parentheses, we could repeat that second group with /2. So in this case, we are searching for any group of any number of letters followed by a space followed by any number of letters that are the same letters as before, because we're doing /1. If we test this regex against this string, it's going to return true because it has any number of letters, it has a space, and then it repeats any number of letters, the same letters from before. So that's any number of letters, the space, and then we're repeating the same letters as before. Now, here, where we did /1, we could have just put this whole thing again, the parentheses with the /w. I'm going to copy and paste here. So this would have been the same thing. But instead of repeating this twice, we can just put /1 to save space, so we don't have to repeat if we want to repeat the same search over and over again in a regex. So if we look down here for the match, at first this may seem confusing what it's returning. But what it's returning, the first element in the array is the full match. So that's the any number of characters plus a space plus any number of the same characters. So the full match is this. And then the second element in the array is just whatever is in the capture group. This is the capture group. And what's in the capture group is just regex. That's why we have regex, which is the full regex. And then the second element of the array is just regex, which is just the capture group, the thing in the parentheses here. So down here, we are going to attempt to use capture groups to match numbers that are repeated only 3 times in a string, each separated by a space. We want this regex to match something like this, 42 space 42 space 42. We would also want it to match something like 136 space 136 space 136. It doesn't matter what the number is. And we only want it to match a group of 3. So we don't want it to match 4 numbers, 5 numbers, 6 numbers, just a group of 3 numbers separated by spaces. So let's see how to do that. We are going to use a capture group. So I'm going to put a parentheses /d plus, that means any number of digits, and that's going to be the end of our capture group. And then it's going to have a space, and then I'm going to put /1, which just is a shorthand way of repeating the first thing in parentheses, which is this. And then we'll have another space and another /1. So this is going to look for any number and a space, any number, and a space, any number. So it's the number 3 times. We're not quite done yet, though, because remember I said we want to match only 3 numbers. So this regex would also match this if the number was in there 4 times, because it would find 42, 42, 42, and then stop, and it would say, oh, we found it, but we don't want to match it if there's 4 42s in a row. We only want to match it. We only want this to return true if there's 3 42s in a row. So that's simple to fix. We just have to have a bracket, or I mean a caret at the beginning and a $sign at the end. So remember, a caret means that we want this at the beginning of the string, and then a $sign means we want this at the end of the string. So adding the caret and the $sign just means we want exactly this. We don't want anything before this. We don't want anything after this. So now this will return true for any group of 3 numbers, not a group of 4 numbers, not a group of 5 numbers. You can search and replace text in a string using the replace function on a string. The inputs for replace is first the regex pattern you want to search for, and the second parameter is the string to replace the match or a function to do something. So let's look at this example. We have this text, the sky is silver. We're going to search for silver. This is our regex pattern. So we're going to do a replace here. We got the wrong text dot replace. We're going to pass in the regex, the silver regex, which is searching for the word silver, and it's going to replace it with the word blue. So this is going to return the sky is blue. Now, you can also access capture groups in the replacement string with $signs. Let me show you what I mean down here. So here we have a string CodeCamp, and then we're going to call the replace function on that string. Now look at the regex. So up here we just use the variable silver regex, which was set to this regex. Here we're putting in the regex directly into the function instead of using a variable. So look at this regex. We have this capture group, which just means any number of letters. Then we have a space, and then we have this other capture group, which just means any number of letters. So that's going to find this code space camp, any number of letters, space, any number of letters. So let's look here. So up here, we just put in the word we want to replace with. But here we do something different. It says $2, $1. So $2 means the second capture group, the second parentheses in the regex. So the second capture group is this, which has matched to the word camp. So we're putting camp at the beginning, and then a space, and then $1 means the first capture group, which is this section, which matched the word code. So this is a way, so you can see it returns camp code. So we pass in the text code camp, and it returns camp code. So that's another cool thing you can do with capture groups when you're doing a replace. So let's get back to the easier one up here. We're going to actually make some changes down here that follows this pattern up here. So this sandwich is good. Well, we are going to find the word good here, and we're going to replace it with the word okie dokie. So here, it's going to find the fix regex, which is good, and it's going to replace it with the replace text, which is okie dokie. This is a regex coding challenge. The challenge is to write a regex and use the appropriate string methods to remove white space at the beginning and end of this string here. Now, the trim method would work here, but the challenge is to do it with just using regular expressions. So we are going to do a replace, but we have to write a regular expression that's going to figure out what we're going to replace. Well, let's write a regular expression that finds all the space at the beginning and all the space at the end. So this is how we'll do this. To find everything at the beginning, it's going to start with a caret, which finds something at the beginning of a string, and we'll put /s, which is all the white space, and to get any number of white space characters, I'll do a plus. Now we also want to find all the space at the end, so I'll do a pipe character, which means or. So all the space at the beginning or all the space at the end. For all the space at the end, we'll do /s plus and then a $sign, which means this has to be at the end. And so we find both the space at the beginning and the spaces at the end. I'm going to add the flag G here. So now we've found all the spaces. We just have to finish this replace here. So hello dot replace, and then in parentheses, first the regex, WS regex, and then we are going to replace all the spaces that it's going to find with just an empty string. So this will effectively remove the spaces from that string. I need a parentheses here. And let's test this out. You can see in the console, hello world, with no spaces at the beginning or the end. Congratulations on finishing this regular expressions course. Well, keep learning and thanks for watching.